Hello? Is it on? Hi, everyone. Thank you for coming today. So my name is Dennison Bertram. I'm with Zeppelin. Today's talk is going to be about upgrade-driven development, which is building modular, secure, upgradable smart contract applications. So Zeppelin. So what are we going to talk about today? First, we're going to talk a little bit about who we are at Zeppelin, Open Zeppelin, secure modular libraries, upgradability, why it's important, how does it work, EVM packages, what are they and what problem do they solve, and what opportunities they offer, and upgrade-driven development, which is architecting modular systems, and finally, our latest product, ZepKit, which sort of ties everything that we're offering together. So, a little bit about us. Zeppelin, we build tools for developers and operators of secure decentralized systems. You may know us. We help companies secure their systems by performing security audits. We're the creators of Open Zeppelin, battle-tested framework of reusable smart contracts for Ethereum and other EVM blockchains. We're the creators of Zeppelin OS, a framework for creating and managing upgradable smart contracts, and Zeppelin, a complete toolkit for developers. So, first, Open Zeppelin. So you probably mostly know Open Zeppelin. We're well known for creating audited contracts that follow ERC standards. You can see here some information about the traction that we have on that. We had 400,000 total downloads in 2018. We recently passed 500,000. So it keeps on moving up. Yeah, that's pretty awesome in this space, right? That's great. Our weekly downloads is 16,346 currently, and we have nearly 7,000 stars on GitHub. So as a metric, that's nice. This is something that's really important to us in the community, that we see that people like what we're doing, that what we're building is helping other projects, and the developers use it, right? This is important. So a little bit about Open Zeppelin. We have thorough code reviews. We have 100% test coverage. It's audited, and of course, we have informal review by the community. And if you ever do find something, please get in touch with us. We're really happy to hear from the community and have that participation. So, upgradability. And upgradability is kind of a hot topic. It's been a hot topic for a little while and tends to be a bit contentious. So we're going to go over it in a little bit of detail on what we're talking about. So basically, upgradability is for the obvious, right? You can fix bugs, you can add features, you can develop faster, and you can be more awesome. Right? And this is important, right? So we love this motto. This is from XKCD. My motto is move fast and break things. And we tend to think about that when we think about development and our sort of field. But of course, moving fast and breaking things is a horrible idea for what we do, right? You want to move as slowly as possible, and you don't want to break anything, right? So I'm not going to read this whole thing, but this is a great quote from the morning paper. Basically, it's talking about the challenges of developing smart contract applications when you are creating an application that you have to get right the first time, that is going to run in an adversarial environment that anyone can call with any variables of their choosing, arguments of their choosing, and there's no legal recourse if something goes wrong, right? Like if they bork your system, you're just... Exactly. So the main part of that that's really wacky for us as developers is the idea that you can never change it, right? Like the idea that we are going to build singular monolithic applications that are going to function today, they're going to function tomorrow, and they're going to function for the next 100 years without any updates, without any upgrades, without any change in what we expect our users to have is kind of wild, right? Like that is impressed upon us by the system that we're using, but that's kind of a crazy idea. So to give you a little example here, I'm just going to walk through it. I'm not going to get too technical. But basically here, my contract, right, my wallet, it's initializable. And we have a function to initialize there. Initialize is a special function in Zeppelin OS, which replaces the use of constructor functions for some technical reasons that I won't get into right now. But so let's say this is your contract, right? You do it using Zeppelin OS. The process of deploying is you add your contract to your project. You push the source code, the bytecode actually, to the network, and then you create an instance of it. And then you have My Wallet version 1.0, right? It's awesome, it's great, it fulfills all the needs that you had when you originally built your software the first time around. But let's say now you want to add features to it, right? So in this case, we go back to our My Wallet contract, and we add a new function, right? In this case, withdraw, right? Pretty simple. when we go ahead and we use Zeppelin OS to, first we push the code, the bytecode to the network, and then we update our wallet, which links it to our new implementation of the logic. Note we have the same address right there, right? Like that hasn't changed. So we have the same address, we have the same storage state, we have the same balance, but we have new code, right? My wallet version 2.0, ladies and gentlemen. Right? But there's a particular reason why I've chosen this picture, right? And I'll get into that a little bit later. I don't know how many of you know this car, but this car is really famous for some particular aspects about it that we'll get into. So, first of all, how does this work? The most important thing is to understand this is not magic, right? This is not a magical process, this is not a black box, and this is not a huge behemoth of code that enables this sort of functionality. What we're using is transparent proxies. And I love this quote, one of our colleagues came up with this, but thank you, Mario, but our implementation is in another address, right? So the way this works, and I'll go into just a high-level overview of this, is basically we're using a proxy, which proxies your call using delegate call to the logic, right? And the important part of this, what this means is your proxy is keeping the storage, right? Because your proxy, when you delegate call through our proxy, or your proxy in this case, you're calling the logic function in the context of the proxy. So the storage is always there. It's not in the logic, right? So if you have an ERC20 contract as your logic, right? And you let's say you deploy it and you say, okay, this is going to be Dennison's token, right? You deploy it, it's Dennison's token. If I were to call the logic contract directly, it would say, I'm Dennison's token. But if you were to call it through a proxy contract, right, it wouldn't say anything until I initialize it through the proxy contract. So if through the proxy contract I call it Dennison's other token, right, I'm using the same logic, but the proxy keeps its own storage. It has its own state. So what does that mean, right? That means because we are using implementations, right, our proxy is pointing to where it delegates our contract calls, we can change that, right? So we can tell our proxy, hey, this was my wallet version 1, and this is my wallet version 2. And we can simply change where we're pointing to. So now in this case, when the proxy is calling my wallet version 2, it still has all the storage from the proxy, right? So all the storage, the name of your ERC20 contract, it's all there. It's not in the logic contract, right? So we can point that around as much as we want. So same state. This is the important part. Same state, new logic, right? Amazing, right? This is great stuff. I'm going to talk about this in a technical way on Friday, so please come by. It's a little bit early, but we're going to actually do a live coding workshop. We're going to go through this on a technical level. I'll explain it in more depth and show you exactly how it works, and we'll go through it. So if you're interested, you can sign up. It's at Friday, a little early, but it's at Consensus. Take that link, just sign up, and then, you know, we probably won't have too much time for technical questions here, so you'll really be able to like rip me apart there. So, EVM packages. So if you think about what I just showed you, there's probably something that's slightly obvious, right? Well, maybe not entirely obvious. But if we have a proxy and that's what's keeping state, and we're just using the logic in the logic contract, right? That means we can create as many proxies to this logic as we want. Right? Because the storage is always in the proxy. It's always calling it in the context of itself, right? Everyone in this case has their own instance of the logic contract. So if that's an ERC20, right? Proxy 1, that might be Dennison's ERC20. Proxy 2 might be someone else's. So we can share the same logic, but we don't share state, right? We're not commingling our state. So this is an example of different tokens, right? You can make as many ERC20 tokens as you want, and we only deploy the ERC20 logic once. So EVM packages are a feature of Zeppelin OS and something that we're working on. It sort of falls into the realm of the research being done on doing package management. But what we can do, what Zeppelin OS allows you to do, is allows you to build a project where we keep track of the iterations of your code. Right, so let's say this is ERC20 version 1, and then you create ERC20 version 2. Remember, when we do that command ZOS push, this code is living on chain, right? This is already deployed. We don't have to redeploy that. Zeppelin OS allows you to iteratively build packages where you say, hey, this is my first version of this contract, here's my second version, and this is deployed on chain. So that allows people who are using your EVM package to choose which version of your code they're using, right? So this allows you to do something really powerful. This allows you to deploy code, iteratively update, add features, and the people who are linking to it, whether it's your project itself or other people that you're sharing publicly, they can choose the implementation that they link to, right? So what problem are we solving here? Potential cost savings, right? If you have a contract that's doing factory functions or a factory contract factory where you are just deploying contracts over and over, that gets really expensive. If you're deploying 1 million instances of an ERC20, why are you paying to deploy an ERC20 every time? Our proxies are very lean, they're very cost effective, so if you just deploy the proxies, right, you have an enormous potential gas savings. Security. This reduces bugs because you're linking to on-chain code, right? You can verify this code on-chain, you can see the source code. What you currently do, and something we highly discourage in the Open Zeppelin libraries, is people tend to copy and paste from GitHub, right? And sure, that's a quick and easy way to get yourself an ERC20 token. That's also a quick and easy way to really mess something up, right? So one of the things that you can do with this now is you can have secure repositories of code, right? You can have instances of code that you know are safe, and when you deploy another ERC20, you know that you're deploying the same audited smart contract that everyone else is using, right? So it adds to your safety. We can create composable smart contracts now, right? So something that people do with Open Zeppelin is they do a lot of inheritance, right? You inherit from the ERC20, and then you add functions and features to it. Something that we saw a lot during the ICO boom was people were taking the ERC20 specification, inheriting from it, adding functions to manage the crowd sale, pay out dividends, this type of thing. Right? But the moment you do that, you lose those security guarantees, right? Because we don't know what's happening inside your code. You don't know when you're introducing bugs. And also you're mixing, you're commingling purposes, right? You're commingling focus of your code, right? The ERC20 token, that should be responsible for securing your digital assets, right? That should be responsible for securing your tokens. That is not supposed to be selling itself in a crowd sale, right? Like that's another type of functionality, and that's what we saw a lot happening with the Open Zeppelin libraries. People were inheriting from them, right? Now we can do composability. Now you can link to these contracts on-chain and call them as you would a normal contract. But now you don't have those fears about mixing the type of functionality that you're supposed to be getting. Private code libraries. A project can only link to whitelisted code. So this is maybe you're on a side chain and you have a large organization around the world developing. Maybe you have a repository of verified whitelisted code that your developers can use, right? Like you don't want a situation where a developer is copying and pasting from GitHub late at night just to get something done. You can say, hey, if you need an ERC20, this is our enterprise's verified ERC20s. You have to use this code. But it goes beyond that, right? Maybe it's data structures. We have some of our partners have created data structures as EVM packages. So maybe you're linking to doubly linked lists. LivePeer has created a doubly linked list EVM package. So you can say, hey, we need a data structure for our contract that goes beyond what you can get with traditional arrays or Solidity data structures, right? But you can say, we're using this verified instance of a data structure. And long term, we're looking forward to a rich world of shareable code, right? We're looking forward to the idea of what NPM did for the JavaScript ecosystem. We would like to see that happening in the Solidity in the Ethereum ecosystem as well. EVM is also a very well-known project, and that's the same kind of idea. What we're trying to do is get people to share code so our development can be faster, so we can be more welcoming to new developers, so we can be more accessible, right? So Open Zeppelin ETH is an instance, well, it's a version of our Open Zeppelin Solidity contracts. We already have the ERC20, ERC721, payment splitter, and token vesting deployed, so you can link to those already. And we've updated the Open Zeppelin contracts to be compatible with Zeppelin OS, right? So all of these will work out of the box. So, upgrade-driven development, right? What are we talking about with this? Traditionally, when we've been building these smart contracts, we've been thinking about single entities that we're building now, and they'll never change, and they'll be immutable. And there's a real value proposition for that, right? We're not saying that nothing should be unupgradable. If applications can be upgraded, however, the question that we always get, and is very important, is who decides when and what to upgrade, right? This is a big question. So important is in this system, with EVM packages, with upgradability, upgradability can have as little governance as necessary or desired, or as much, right? This is something you get to decide. In the EVM packages that I showed a few slides ago, we can't upgrade your code for you, right? If somebody points to your code, no one else can upgrade them against their will, right? This is something that each developer, each user can decide. So looking back, our app, version 1.0. Right? Version 2.0. But of course we know what's going to happen, right? If you do that overnight, surprise, this is what your new application looks like to users, people, of course, they freak out, right? So governance is really an important topic here. And there's a reason why I chose this car, right? This car, it looks sweet, it looks amazing, but when it came out, I don't want to say it sucked, but there were a lot of really important problems with it, right? For example, that window in the front there, right, like right there, that was how you got in and out of the car. But the seat was so reclined that it wasn't possible for you to get out of the car by yourself. Someone actually had to pull you out of the car to get you out, right? So the designers, right, in this case you can think of yourself as the app developers, you think, sweet, everybody's going to love this. But maybe they're not. Maybe you're going to introduce bugs. Maybe you're going to introduce other problems. So for governance, I don't know how well you can see this clearly, but what we have here is, so here's the proxy, right? But you can use multisigs, you can use DAOs, you can use voting contracts to control these proxies. These don't have to be things that just the developer has control over. If you think of something like a game, right, a blockchain game, where you have 3 different components. You have the thing that stores the user's tokens, you have the gameplay, and then you can have some sort of interface for external applications, right? Those 3 things can all be upgradable. If you build them as EVM packages, they can all be composable, right? You can keep the functionality separated and isolated, and the governance mechanisms that you can use for it can vary based on what the needs are. Right? Maybe the interface is something that the developers at the company should be responsible for dealing with, right? Maybe you trust them to handle the interface. Maybe there's a DAO that organizes and controls the game mechanics, right? The players get to decide how their game is going to be playable in the future. And then maybe no one can upgrade the tokens, right? Maybe the ERC20 is fixed forever. But what it also means is you can do selective upgradability now. Right? And that's what I just mentioned, right? You can choose what piece of your application can be upgraded, how it can be upgraded, and you can use things like EVM packages and composability to separate the parts of your application. So maybe in the future, version 3 of your app looks something more like this, right? So if you start abstracting out these aspects, maybe the users get to decide what the tires on their car app look like. Maybe they get to decide how the car drives or what sort of engine it is, right? Maybe they have the ability to choose all these different versions in that. So something that this brings up then, of course, in the governance is the idea of trust. And this is kind of like a nice quote. Users generally trust Tinder to match them with hookups, right? And I'm sure some people in the audience here use Tinder. But the question is, do you trust Tinder with the messages you send to the people you hook up with, right? And that's an interesting paradigm because up until now, your trust in applications has been binary. It's been monolithic. If you agree to use Facebook, you have to trust Facebook completely with all aspects. If you use Tinder, you have to trust Tinder completely with all aspects. And we know that not all aspects of Facebook are good custodians of our trust in the same way, right? We trust them to update our pictures. We don't trust them with the content of the pictures or social network or a graph. So upgrade-driven development. Trust no longer needs to be monolithic for our applications, right? We no longer have to build applications where we are requesting all or nothing trust from our users. We can now involve our users in this discussion, in this process. So upgrade-driven development, this is something I'm working on. It's a work in progress, so I really appreciate feedback. But it's an iterative process, right, that builds on the idea that you create something, you put it in production, you upgrade it, right? Just the same way you do test-driven development, which has become the norm, you do upgrade-driven development. You pass tests, but the ultimate test is how do the users use it, right? Because in that slide way back before, we're doing something really special. We're developing software in an adversarial environment where we have no control and no recourse, right? There's no unit tests that are going to really test how users use your application in the real world. There's no unit tests that are going to show you how your application plays nice with all the other applications on the blockchain, right? So upgrade-driven development is also design consideration that when building upgradable software on immutable networks, users have different expectations of us. Right? You may be building a simple game, but you may be holding someone's life savings in that game at the same time. Right? That's different from Candy Crush. Right? If Candy Crush loses all your gems, nobody gets hurt. Maybe people are a little bit hurt inside, right? But nobody gets hurt. But we're building games. We're building simple applications that can really hurt people. Right? It is the understanding that the shape of the networks that we build on are fluid and require robust, non-fragile software. Right? Like move fast and break things. That's great, but you got to be able to fix it too. Right? If you break something and you swallow up millions of dollars of somebody's money, you got to fix that as well. And you have to have that ability, but you have to have the proper governance for that as well. Software can be abstracted into areas of upgradability, responsibility, and governance. We went over that. That's the composability of smart contracts, right? And something that comes up a lot now is that as we see more people moving to side chains, the cost effectiveness goes up, right? Before, in some of these cases, right, you might say, hey, I'd love to compose my software, but that's going to add a lot to my costs. Well, now if you're developing on Loom, if you're developing on XDAI, if you're developing on sidechains, right, maybe that's not so much of an issue anymore, right? We've seen in the past couple of years this drive to move as much application functionality off-chain, right? And what has that done? In some ways, it's made our creativity in solving problems go up. But in some ways, it's made the software that we've created become less creative on the blockchain, right? There's things that we can't do on the blockchain because of that. But now, especially with sidechains, we can. And so users can participate in the shape and design of the software they use, right? So that's something I went over before, right? You can involve your users in this testing process. You can involve the users in this governance process. So finally, we have ZepKit. And ZepKit is our latest offering, and ZepKit is an all-in-one toolkit, right? Zeppelin OS. It includes, well, not all that stuff, but the problem that we're trying to solve with ZepKit is if you're getting started with an app today, if you're doing the hackathon this weekend, there are too many options, right, for what you want to build and develop on. We have too much boilerplate, right? You have to do too much before you can actually launch something and test something. There's too much friction, and there's simply too many pieces in the ecosystem right now. And a big problem of that is not all the pieces work, right? And not all the pieces are interoperable. So when you're getting started, there's a lot of friction to going from zero to an app. So what we're trying to do with ZepKit is we're trying to reduce this friction. And this is a new offering, so we are really looking for feedback and input to add things that people are looking for. It includes OpenZeppelin as the EVM package, so you already have that in there. You already have OpenZeppelin, Zeppelin OS keeps track of EVM packages, so you already have the ability to deploy ERC20s, which are already on the mainnet. You have upgradable smart contracts with Zeppelin OS. We include in Fura, you have a token, API key already in ZepKit, so you can deploy right away. You don't have to go through the friction of like signing up and getting a token. API key. We have Truffle to compile and test your smart contracts, React and Rimble to build usable and friendly interfaces, and we're adding things more and more, right? So we just had an announcement yesterday regarding our cooperation with Tabuki and the gas station network. These are things that we're looking to build in. We're looking to hear from developers what they want to have, one-click access to when they're developing so they can get started. So show me what you got. That's basically like go out there, build stuff, try things, right? Experiment with things. These are new ideas. They're kind of crazy. Certainly upgradability has been in the community for a while, but it's really a discussion of how do we make this something that we use. Join our forum. If you email me, you can get a copy of these slides. Also, on Friday, we're going to be doing the live coding workshop, so you'll be able to come and really like tear me apart. I don't know how much time we'll have for questions here. And of course, we are hiring. We're really moving fast right now, and we're hiring aggressively. So please drop an email to jobs@Zeppelin Solutions if you're interested. We're looking for a wide variety of profiles because we're building some awesome stuff, and we want you guys to be a part of that. So, thank you. Questions?
Okay, sorry. My question is really simple. Would we ever have proxy contracts without interfaces?
Can you be more specific?
Yes, I mean, I've been working on a upgradable contract, and I see that as a limitation, we have to, on the proxy contract, define the interface, right? Because then with the delegate calls, you have to specify the function under the hood. So the question is, could we have a fallback function maybe in the proxy contract able to redirect to the call to a proper function implementation?
I don't know, actually. That's a good question. I'd love to talk to you more about that, because I think I understand it one way, but maybe you mean it in a different way. Certainly, you can call arbitrary functions with the proxy. No, let's talk after. I'd like to understand better what you mean. Yes.
All right. Nice, eloquent talk. So in Etherscan, it's really hard to audit and browse the code from projects that use upgradable contracts. And I imagine it's going to get way more difficult when you have tons of functions from a bunch of different proxies. So what's a good way of reading a live contract's source code if it uses Zeppelin OS?
That's a great question. I'm so glad you asked. Coming actually in a future version of the Zeppelin OS, I believe in 2.3, there is the ability to verify contracts with Etherscan directly from Zeppelin OS. So you put in your Etherscan API key, and then Zeppelin OS will verify the code on Etherscan. So yeah, that's something we're concerned about, and we're making sure that we have support for.
I'm not really familiar with the latest development of Zeppelin OS, but I'm familiar with ERC 1538 with the transparent proxies.
Can you speak a little louder, please?
I'm familiar. I don't know if you're familiar with ERC 1538 transparent proxies. Basically, what they do is for each function call, they look up a table which delegates to use for each member function. So do you have similar functionalities, or how can a proxy basically divide its call between different delegates?
So I think you're talking about there, I didn't look at this in depth, but I think you're talking about there is an EIP that talks about doing upgradability on a function level, right? So definitely Zeppelin looked at that. So I believe the name of that was the vtable implementation that we looked at initially when we were investigating upgradability. They did decide against it for a couple of reasons, which I don't know offhand. I think it had to do with the fact that it's a little bit more cumbersome to do. It's certainly a process that you can do. I'm not entirely sure if that necessarily gives you an advantage over the composability of EVM packages in and of itself, right? Like if you have a contract that's dealing with specific type of function, right, that you've isolated into just its functionality, then if you're changing a function inside of that like pack of functions, maybe you're better off creating just an entirely new implementation than just upgrading per function basis. But yeah, oh yeah, that's true, that's true. We've definitely thought about that. There were some discussions that I wasn't a part of about that. We could certainly talk about it more. I think so far that hasn't really been a problem. You certainly could abstract your contracts into smaller pieces, but I get what you mean. You get around the limit. I would love that we have a future where smart contracts are all that big, though. That means we're building great software. Cool, thank you so much for coming. And once again on Friday, if you want to tear me apart, we'll have a live code. Thank you.